So, okay, if you use American standard, they have some different parameters, which is although they are close, and they ask that I should go faster. It's loading. I need to see the graph. See there's the graph because it has to. Okay, the next one. Good, next one. Good. Yeah. If you see the red line, you see for material of the same concrete strength, the same strength. When you do comparison, you have the same strength. Let's assume the strength is 20 newtons per meter square, You see that 20 is cutting across. It means that if I use Leica as a material, Leica is an aggregate from clay. If I use that for the same strength, I will get less than 3.3 or thereabout. That means that I'll get 3,300. That means if I were to classify it based on those parameters I showed you, I will just say that it is not a very good material. But if I use gravel, I'll be getting 4,300, 4.3 kilometers per second. That's 4,300. So that means that for these materials, for the same strength, you will actually be getting different velocity. So that is one of the downside of the ponding test. The next graph also shows you the same thing. If I were to use granite, or I use gravel, or limestone, for the same strength, I'll be getting a different velocity. So that means that the velocity I get will be misleading. Then the next one talks about the smell. Now, the cement and aggregate mix also have impact. The graph there tells us, next slide. Yeah, tells us about the mix. So the different mix gives us a different compressive strength, and they also affect the strength. And then the next one tells us about the ratio of the concrete, the age. So now I'm going to just skip a number of things because the MC is on my neck. So now the effect of reinforcement. The effect of reinforcement, when you do this test and you have reinforcement. Can you hear me? Okay. So when you do this test and you have reinforcement in way of the energy propagation, the sound propagation, it has an effect. In fact, research has shown that when you have that, it amplifies the velocity by 1.2 to 1.9 times. So if I have a weak concrete, but where the test was conducted, there is a rebar in that area, it will turn out a good result. And so it's not giving the right impression of what it should be. So I'll just keep most of this what I want to say. Now, the other one is the factors. I would like to see it because that is where you see the two layer separation, where you have what we call the plaster and then the concrete. You see the graph that is plotted. You can now get the velocity of the sound in the concrete and the time is going to return. So you can see how you can get the velocity of concrete and how it's going to return. So you have water and then the concrete. That's right.
You see the mortar and the concrete. You see how the energy that's the one in red. You see the source of the energy, that's the transmitter, and then the receiver at the other end. So because there's a rod that is running parallel to the beam to transmit, and if you look at it below is a graph that tells you how to get this relationship, and the formula is there. And if you look at this table, next one. If you look at this table, you will see that you have under the water concrete ratio, you have 0.4, and then 3 sets are 0.5, and then the third set is 0. And the thickness of the plaster or the mortar is 3, 10, and 15. And you see that they all gave you velocities. So that tells you the impact of velocity of the thickness of the mortar on the velocity. Now, the rebound hammer test. I'll just go through this very fast so I can. So that's that. Yeah. So that is the. So I will not go through this. Let me just go.